All right, another example of factoring out the greatest common factor, GCF, of this polynomial expression. Now, you got two variables in this case, the variables x and y, going with the coefficients positive 7, positive 28, and negative 14. Well, let's break down each term into its respective prime number multiplicative factors first. Okay, so that's the long way to do it, and then at the end I'll show you the short way, which requires mental math, but you know it's easy for you guys. So looking at the first term, 7 times x times w, well, we know for number 7, it is a prime number because the only multiplicative factors of positive 7 is just positive 1 and itself. Okay, and then of course x and y stay the same. What about this one? Over positive 28x squared times y. Let's see. Well, when we think of 28, people like to think of, as 4 times 7. Okay, and then x squared just x times x, y just by itself. Well, hey, we got prime number 7, prime number factors, x, and y. But not number 4. Number 4 is a composite number, so we can rewrite number 4 into the products of two smaller numbers. And fortunately, those two numbers, which are also prime numbers, are positive 2 and positive 2. And then bring down everything else. Well, the same thing for negative 14. Well, negative 14 is something that we always see, or more often than the other. Negative 14 is the same as saying negative 1 times 2 times 7. X to the third is just x multiplying itself 3 times. Y squared is just y multiply itself 2 times. Well, hey, negative 1 is a prime number. 2 and 7 are also prime numbers. Each of these x and each of these y is also a prime number factor. So hey, we got there. We got 3 lists of prime number factors of the first, second, and third terms. Well, let's collect everything. Let's compare it. For positive 1, well, positive 1 we have in here, and of course positive 1 is also in here as well, but it just, we recognize the fact that anything by itself, it is same as itself multiplying positive 1. And let's see, in here, well, in here, we also have the visible positive 1, so let's just rewrite this a little more. Negative 1, this whole thing is the same as what? Positive 1 times negative 1 times 2 times 7 times x times x times x times y times y. Well, hey, that's the invisible positive 1 right there, because again, anything by itself is the same as itself multiplying positive 1. So positive 1 is part of the GCF of this expression. What about the positive 7? Well, we got positive 7 in here. We got positive 7 in the second list and in the third list. So hey, that's another one. What about the x? Well, we got one x in here, another x in the second list, and another x in the third list. So that's another part of the GCF. What about the y? We got a y in here, we got a y in here, we got a y in here. Okay. Well, in the first list, we don't have anything else to consider. So that means everything else will be leftover. Okay. So the greatest common factor in this case is going to be 1 times 7 times x times y. 1 times 7 times x times y. 1 times 7 times x times y. Multiply by the leftover. Well, in the first list, we already took out everything. So the leftover is just, positive 1. In the second list, the leftover is 2 multiplying 2, and then multiplying x. So positive 2 times 2 times x. In the third list, the leftover is negative 1 times 2 times x times x times y. All right. Well, 1 times 7 times x times y is just 7xy. Multiply positive 1. Let's see, positive 2 times positive 2 is positive 4 times x is just positive 4x. Negative 1 times 2 is negative 2. Negative 2 times x times y. Well, x times x is x raised to the second, so we have negative 2x squared times y. This is the factor form of this expression when we factor out the greatest common factor. Okay, so that's the long way to do it. Now, what about a short way? Well, a short way is going to require mental math. So let's just say we have the same expression, 7xy plus 28 x squared y minus 14 x cubed y squared. Well, hey, as stated in the previous example and at the beginning of this video, we noticed that we have the variables x, y going with all three of the coefficients. So whenever all of the coefficients have a common variable, we have to factor out that variable that has the lowest exponential power. All right. So with the coefficient positive 7, we have the variable x. Well, the variable by itself is the same as that variable raised to the invisible positive 1 power, and same thing for the y. Right here. Right? So the coefficient positive 7, positive 28, and negative 14 has the common variable x. So we have to factor out the x that has the lowest exponential power, which is x to the first. So we bring it to the outside. Oops, well, I don't know why I write that. Well, not yet, for the parentheses. Now for the y variable, all three coefficients also have the y variables in common. So we have to factor out, we have to factor out the y with the lowest exponential power, which is the invisible positive 1. So factoring it out. Okay. And then we don't have any other variables, so we're good with the variables. And now we take a look at the coefficients. Well, the coefficients, the smallest coefficient, positive 7, is a multiplicative factor of itself, of positive 28 and of negative 14. Okay? Because 7 is the same as 7 times 1. Okay, so if we factor out the 7, we're left with what? Let's see. So 7 times x to the first times y to the first. Well, basically this whole thing is the entire first term. So we factor out the whole thing. We get a leftover positive 1 plus. Well, let's see. We factor out the positive 7 from the positive 28. So the leftover of positive 28 after we factor out a positive 7 is going to be positive 4. What about the x squared? Well, we factor out x to the first already. So the leftover of x squared in here is going to be just x to the first. We factor out y to the first from here. Well, that means there's no more leftover for the second term. What about the third term? Well, negative 14 is the same as positive 1 times negative 2. So we factor out we factor out the positive 7 already. So the leftover of negative 14 is just minus 2. We factor out x to the first from x to the third. So the leftover of x to the third after we factor out x to the first here is just x to the second. After we factor out y to the first, the leftover of y to the second, just y to the first. Okay, so this is the same as saying 7xy multiplied by 1 plus 4x minus 2x squared y. But hey, guess what? That's the same as what we have up here. You see? So there's a long way and there's a short way. The short way is going to require a little more mental math. So if you're more comfortable with this, use it. But if you want to be sure that what you're doing is correct or the work that you're showing is correct, go with the long way. All right. So yeah, just you know, you have to know your multiplication, and you have to know, like you have to be able to see a little ahead. If you ever decide to go with the short way, that requires mental math. Okay, and like again, I usually what I do is that to determine whether or not I can factor out the smallest coefficient or a factor of the smallest coefficient from the smallest coefficient itself and each of the other one, I usually ask myself, like, is there like a common factor of, is there a common multiplicative factor that goes into all of these coefficients? Well, in this case, the smallest coefficient is positive 7, and positive 7 happened to be a multiplicative factor of itself, of 28 and of 14. Well, it is a multiplicative factor of itself because 7 times positive 1, it's just positive 7, so right there. And it is also the multiplicative factor of positive 28 because we know positive 7 times positive 4 give us back positive 28. And same thing for negative 14. To come up with negative 14, if we take positive 7 times negative 2, we get back negative 14. So that's how I realized that the smallest coefficient, in this case positive 7, is a multiplicative factor of itself, of positive 28, and of negative 14. Okay, so I know that's a lot to explain, but hey, factoring out the greatest common factor as well as factoring out anything else that you'll be doing in the future or that you'll be reviewing requires a lot of mental math. Okay, all right, thank you for watching. See you guys next time.